extend very wide area. So how much excavate can you do that, right? So excavation and also when you carry the polluted soil from one place to another with your, it is another source of pollution. Okay, so this there are some disadvantages. So people are thinking how to do some biological way, okay, biocontrol of the. So as I mentioned, agricultural pesticide and like to kill the pest is one of the most used chemicals in the agricultural field. So can we do like, if it is like biocontrol, by selecting some special crops or special things which is biological, that could reduce the pest, that could reduce the insect. Okay, so this is one of the like recent trend, or organic farming. So in organic farming, people do not use the chemicals, they choose something like a cover crop as a biocontrol for a specific pest. For example, if you grow cilantro, okay, coriander plant, it has some strong smell, herb, so many insect will not come to that crops. So if you put cilantro inside your cauliflower garden, for example a tomato garden, then you can reduce the amount of bad insect or something like that. This is called biocontrol. And sometimes if you use some source of compost or organic manure, normally what is now applying in the organic farming, so that is also have good impact to control the disease. And sometimes good insect is used to kill the bad insect. Okay, so there is some biocontrol way, like in many countries now trained birds are applied, like eagle or something, to catch the mouse from the grass feed or farm feed. So they do not use any chemicals or any other things, they try to do that. So if the soil pollution happened, so you have to have this information before going to the site, like what kind of material causes that, whether it is organic or inorganic, and then how much material was added to the soil, what is the carbon nitrogen ratio of the material, or how much they added nutrients, and that what type of soil that one, and what is the growing condition of that, and how long has the material been. So these are the things you have to know when you go for cleanup or doing some works in the polluted soil. So I think many of will have in the future this type of challenges like soil pollution. So at that time you have to think those points in your mind, like what type of, not only what type of soil, what type of pollutants, and what is the environmental condition, growing conditions, and whether it is immediate danger to the people or not. So if it is immediate danger like radiation or some volatile materials, then you have to keep the guard, like people should not go in there, like general people or children especially. So we have to take immediate action before doing any treatment or further. So now last 10 minutes we'll talk about bioremediation. So this is one of the recent approach to clean the soil pollution. Not only soil pollution, many other like water pollution and some other pollutions can be also treated by this bioremediation. So this new technology is using friendly bacteria to clean up the pollution or polluted material. This is one example this is carbohydrate, any gasoline for example. If the soil is polluted by this oil, for example, the microorganisms will eat that soil. Okay, they can eat anything, any carbohydrate they can eat. Hydrocarbon they can eat, and after eating, by their metabolism, they can break it to carbon dioxide and water. So when oil is very much serious pollution, okay, for the soil. By the bacterial metabolism, it can be broken to carbon dioxide and water, and then they will release that to the atmosphere. So your soil will be clean. So this is an example of bioremediation. Okay. So this is very environment friendly approach because you do not need to use any other chemicals, and you can do it in the same place where the contamination happened, or you can take it to other place and do that. So you have some flexibility, and it is of course cheap, okay, compared to other traditional methods. But it has also some limitations because so far they are very good to clean the hydrocarbons or like other organic solvents, some metals, but they are not good at heavy metal, okay, so far, because they cannot, the bacteria cannot withstand with a very toxic environment. So here are the some advantages or good points of bioremediation. Like bioremediation can be employed in areas that are inaccessible without excavation, and sometimes in natural process, so no need any chemicals for the treatment. So if the soil is polluted for a vast area like kilometers, 10 kilometers or something, like what happened after the tsunami, okay, natural disaster. So in those areas, it is very difficult to clean up with the traditional method. For example, one of the traditional methods is to wash with the fresh water, but you cannot imagine how much fresh water it will require for this type of area, and how to manage the after washing that soil, okay, where you treat the water or something. So for those area, bioremediation is very, very good. So we did, our research team did some field experiments in the northern part of Japan after the tsunami affected area. So we cleaned the agricultural field by using some microbes, friendly bacteria. Okay, we prepare the bacteria, mixing with compost, and then apply in the field, and they work very well. Okay, so bioremediation is also very good for the vast area, and if it is polluted by the, like I mentioned, some other hydrocarbons or like some metals or even salinity, then it is very much useful. And what should you monitor during the bioremediation? So you have to check the redox or oxidation reduction potential, and you have to check the pH, whether it is acidic or basic, temperature, oxygen content, okay, and what is the breakdown products like carbon dioxide or so. So these are the things during the monitoring of the bioremediation. So any other treatment options, you have to monitor your soil. For the case of bioremediation, you have to take care about these 6 points. So this is very important. But there are some things like what is the conditions that favor the bioremediation, like bioremediation is microbes will be happy to work. Okay, so you have to think the favorable temperatures, the water available. If it is too dry, bacteria cannot survive. So you have to apply some water. And if, whether they have enough food, and bacteria's food is like nitrogen, phosphorus, potassium, the nutrients. And you have to check the carbon-nitrogen ratio, CN ratio, and whether there is enough oxygen or not in the soil. So these are the things you have to check during the bioremediation process. And there are two types of bioremediation. One is in situ bioremediation, another one ex situ. In situ means it will be treated in the same area where it is a pollution occurred, and ex situ means you will take out the soil from the polluted area to other area and then treat that one. So there are two types of bioremediation process. And in situ is like this. One example of like this. This is contaminated soil or polluted soil, and you will supply the food to the bacteria, like nutrients, as I mentioned, or like water or oxygen. Okay, and the bacteria will be active after getting those food and water and everything, and they will work here. So this is one example of in situ bioremediation. So this is very much good, like less expensive, create less dust and less possibility of contaminant release to the environment, and good for large volumes. But disadvantage is a little bit slower and doesn't work well in clays or highly layered subsurface. If there is clay, it will not so good. But ex situ, it is easier to control, okay, and used to treat wider range of contaminants faster, but the problem is costly, as I mentioned. So you have to excavate the soil, take out, carry with your truck, and then treat. So it has some cost involvement. The last one is this is also biologically treatment of the polluted soil. It is called phytoremediation, and it applies some plants. Living plants can clean the soil. This is very interesting. And how do they do that? I mean, for example, if there is some pollution here, and you put or plant one trees or like small plants, they can take out the pollution from the soil by their roots, okay, and they will take it in their plants. So this is very interesting. So especially, I think all of you are familiar with this plant, this fern, and these fern are very good to take out the pollution from the soil. Even like radish and some other vegetables, they can take out the radioactive materials from the soil. They're very strong. And like sunflower, everybody is familiar with that. They can take out the sodium from the soil. So there are many plants. This is of course environment friendly, and they can be used widely to take out the pollution from the soil. But it has some limitations, like it can clean only their root area. Okay, if the pollution is go very deep, they cannot clean that one. And sometimes it grows slow, and sometimes it is difficult to survive in the plants in the contaminated soil or something. So, but this is another new technology to clean up the pollution, clean up the soil pollution. Okay, so not only bioremediation by using the microbes, but also living plants can clean the soil. Okay, so that's all. If you have any questions, you can ask me.